Here's integrated 3. This is part 3 of the lecture for 4.3.2. So I'm gonna try to share my screen. And I'm doing all this because I'm having trouble showing Desmos. Let me hope that you are hopefully you are looking at Desmos on my screen right now. So 4-74, that's where we left off. And it says the Style and Comfort 5K race for charity is coming up. The Style and Comfort Headwear Company expects 775 racers based on a model for hat size distributions for all women. They will need to order hats for the event. On your calculator, recreate the relative frequency histogram for the 40 women's hat sizes in problem 4-61. Use an interval from 50 to 57 with a bin width of 1. So I think we did this one in class. So I grabbed this data, and so the way that if you don't remember how we did it in class, you go into Desmos, and then you have to name your data set. So I like to use the letter L for list, and I go L1, and it makes it, L with a little subscript of 1. Then you hit the equal sign and a square bracket. And there's 40 decimal numbers in there that are separated by commas, which is very hard for me to type. So what I did this time is I opened a Google Doc, and I did voice to text, and I spoke the numbers into the Google Doc, and then I copied and pasted them and landed them into this list here. And it worked out a little faster for me than typing them. But anyway, you have to type the list. And then when I was done with that, I wanted to make sure that I didn't misspeak or mistype any numbers. So if you just type the word total and then open some parentheses and put L1 in there, because that's my list, it'll give you what we call a checksum. And there's a checksum in your book on the original problem 4-61. And so you can see if those match. And if they match, you didn't mistype anything and that all your data is correct before you start working with it. So I've been asked to recreate a histogram. So really, for the histogram, all I had to do is you can actually just type the word histogram, and then you go L1 because it wants the data set, and then it wants the bin width. And they told me to use a bin width of 1. And then, so I'm going to go ahead and do that. I want a relative, so I put the relative button, and I like it left aligned, so it's left aligned. And so that's my recreation of the histogram that we had in problem 4-61. And now letter B wants me to use the mean and standard deviation to make a model of the data with a normal distribution. So to get the mean, I just typed the word mean, and then I used parentheses and put the L1 in there, and it gave it to me. And standard deviation, you can type STDEV, or you can go down to this menu under functions, and you can go search for it. It's under statistics, and it's right there. So I did that, and then I needed a normal distribution. So you can either type normal dist and open parentheses and put the mean, comma, standard deviation by cutting or copy and paste, or you can go down in your menu and find it there under distributions. You can just hit that one. So let me turn that one on for you so you can see it. So there's the normal distribution. Anyway, there's our normal distribution. That is a model that models the histogram that we have there. It's kind of like a line of best fit. So that's what they wanted us to do for letter B. And then letter C says, using your model to represent all women, determine what percentage of women racers wear a size 51 hat. Shade this proportion on a new sketch of the model and calculate the proportion using normal CDF on your calculator. How does the percentage predicted by the model compare to the percentage observed in your sample? So first, let's just go ahead and use the model. So they want a size 51 hat. So see this little, the little check, when I check it, how I can put a minimum and a max. A size 51 hat is anywhere from 51, I don't know, 0.0 to 51.999. So I'm going to go from, well, I'm just going to say from 51. The way our bins are going, I can just say from 51 to 52. And this is going to give me, see how like that's the percentage. And you can kind of compare it with, see the block or the bin underneath it. It looks like, I don't know, it looks like it's like a maybe an underestimate of what the real number would be, but we come to this, it's about 9.8%. They said, how does that compare to the percentage observed in my sample? Well, my sample had 40 numbers in it, and this bin right here between 50 and 52, I can get the height of it. I don't know if you guys know this. I can find the height by, instead of going to relative, I can go to count. Oops, okay, count. And then I'm going to have to do a zoom fit so I can get to the top of it. The count, see how I can look over here and I see that the height of this bin is 5. So the count was 5 there. So that means it's 5 out of 40. So 5 data points out of all 40 were between, they went into that bin from 51 to 52. So if I go 5 divided by 40 on my calculator, I end up with 0.125, which is about 12.5. And this model only predicted about, like, instead of 12.5%, it predicted about 9.8%. So, and you can tell that because, like, if I took this red part and stuck it in here, see how it's like a little underestimate. So it's not perfect, but I don't know, it kind of works. It's useful. So now I guess that answered letter C. Letter D says, how many size 51 hats should Style and Comfort order for the anticipated 775 racers? So I know that it was 0.0. I'm just going to use this 0.09. This is the decimal for the percentage of hats that we need. And I know that in the very beginning of the problem, it said there was going to be 775 racers. So I just got my calculator and I'm just going to go 0.09. So I just typed the number in. I probably should have just done it on Desmos, but I typed the number into my little calculator and I'm going to multiply that by the 775 racers. And that gives me about 76.2. So I'm going to say that amounts to about 76 hats. So that's what they wanted for letter D. So you can actually use this if you're actually, you know, organizing a race and you're trying to order some hats. You can use your model to predict. I mean, at least you can get close. now letter E says, use the model to predict how many of the racers are expected to have a hat size smaller than 51. So smaller than 51 is going to look like, I would think not that many, but smaller than 51 would mean up to 51. So I'm going to have to write negative infinity. So that gives me about 1.8%. So, and if I use that as a decimal and multiply, so if I multiply 0.01857 times the 775 racers that we think are coming, I get about 14.39. So I'm going to say that's about 14 well, it's about 14 racers that are going to wear that size hat. So I might consider, you know, ordering about 14-ish of that size hat. So that's letter E. Letter F says, how many racers would you expect to have a hat size of at least 56? At least 56. So that would be a minimum of 56. I would think not so many of them because 56 is like pretty big. I have to write infinity. So yeah, I'm seeing that only move it 2 places to the right, less than 1%. So 0.857 or whatever are going to have, oh, it says how many racers. So I think I have to take that decimal that I got, the 0.00857, that whole number, and multiply it by the number of racers, which is 775. And I get actually about 7 people. So there's 7 hats. So maybe I should order about 7 hats that are, you know, at least size 56. And then it says, what about a hat size from 51 to 55? And I'm going to get rid of this histogram because I feel like it interferes a little bit with being able to see. Okay, so they wanted how many hats? Lost my place. 51 to 55. 51 to 55. 51 to 55. Okay, so that's 91.33 or whatever. And how many racers? So if it's asking me how many racers, I need to just take that number, the 0.91, just take that whole long number, type it into my calculator, and multiply by the number of racers, which is 775. And that gives me about 754 racers. Wait, sorry. 0.91. I think I lost my place and I'm running out of time. Okay, I'm going to end the video because last time I made it too long, and then I'll finish it later.